Our last section from Chapter 8 is 8.3, a population proportion. A population proportion. So we are still dealing with confidence intervals, but now instead of actually computing data, taking data and computing a mean and a standard deviation, we're talking about proportions. For instance, if you want to know the percentage of people that are planning to vote for a certain candidate. So we're not taking individual data points, we're taking a percentage, a proportion. So let's just say 40% of the people choose a specific candidate. Well, since we're in election time, we'll say Biden. 40% of the Democrats say that they will vote for Biden. And they tell you, the pollsters say that this is within 3 percentage points. Within 3 percentage points. So quite often election polls are calculated with 95% confidence interval. So when we want to know, clearly it's not exactly 40% of the population or the Democratic population that is going to choose Biden. It's somewhere around 40%. So we would say that the interval, we are 95% confident that our interval will be, we're going to say 0.4 minus our 0.03 and 0.4 plus 0.03. So that interval will be 0.37 to 0.43. So we are 95% confident that the actual number of Democrats who are going to choose Biden are going to be between 37% and 43%. So this is what we're doing for 8.3, is these confidence intervals. All right, so there's a few things that we need to know. For the most part, we're just going to use the calculator, but I believe on WebAssign you might have to be able to calculate some sort of a mean. One thing to note is that p hat, so remember p, let me just remind you from the chapter, I don't remember which chapter it was where we did binomial distributions, but p is going to be what we call the success. Remember, the success is loosely defined by whatever we're looking for. And Q is the 1 minus P. I guess we could call it failure, but again, failure is relatively defined here by what we're looking for. In this case, the success is those who voted for Biden, this case. So we're not making any judgment calls here. We're just saying we're looking for the percentage of people that are saying they're going to vote for Biden. And the Q would be everyone else, would be the 0.6. So again, failure has to do with what we are, the 1 minus the P, 1 minus 0.4, what we are not looking for, or, the other side of the story. So P hat is going to be our estimate, or sometimes it's P prime as well. Let me switch back to black. So, or P prime. So this is going to be the estimate for the population, estimate for the true population proportion. All right, so again, N is still our sample size. N is still our sample size as before. P is the success. X is the number of successes. So not the proportion, but the actual number. And I think that's all we need. So the error bound, the EBM, it's really not a mean. It's the error bound proportion. Let's erase that M there. Error bound for a proportion. For a proportion is found by EBP is equal to that same z of alpha over 2, meaning that tail, times the square root, the entire thing is under the radical, of that p prime, that would be our estimated proportion of successes, times the q prime, the estimated, that would, q prime is going to be 1 minus p prime, divided by n, all under the radical there, if that's not, to make sure that's clear. All right, so that's how we're going to find the error-bound proportion. So we also need to know how to find the standard deviation. I'm going to give you the final version. We're not going to algebraically come up with anything here. So we're going to say it's a normal distribution of p, our proportion there, and the square root of p times q divided by n, and our z-score will be p prime minus p divided by the square root of pq divided by n. All right, so let's do an example. Again, we're going to go straight to the calculator here. Go straight to the calculator. All right, so we say that for a class project, we're going to estimate the number of students who are registered voters. The number of students who are registered voters. So we survey 500 students. Survey 500 students, and we find that 300 are registered. So we want to compute, whoops, I lost my pencil here. Compute a 90% confidence interval. I'll put CI again. For the true percent of students who are registered voters. And then we'll interpret that. All right, so let's go straight to our calculator. Change my color here. Calculator. And we're going to go to stat. And then over to tests. Same places we've been going. So stat, tests. Then we're going to go down to, if in mine, the TI 84 plus, if you go all, you notice how each one of these have a number, 1, 2, 3, 4, 5, 6, 7. If you go all the way down to A, and in mine it's A1, it will say, actually, I'm sorry, it's just A, and it is 1 proportion Z interval is what we're using here. And then you're going to hit enter. All right, so you notice that when you get there, you're going to get an x equals, or an x colon, n colon, c level. This is what mine looks like. And then calculate. Oops. All right, so in this case, our x is going to be the number of our, sorry, I've got phones going off here. X is going to be, we set up here, that X is the number of successes. So how many, in this case, we're going to define success as people who are registered voters. That's how we're defining success. So how many are registered? 300. So that's going to be our X. And our N, remember we said N is always that sample size. How many did we survey? We surveyed 500. That's going to be our N. Our confidence level was given to us. We wanted a 90% confidence level, so we're going to put 0.9. And then we're going to hit calculate. And you should come up with 0.564 to 0.635. So what we can say, let's interpret that now. We can say that we are 90% confident that the true proportion of students, the true proportion of students registered to vote is between 56.4% and 63.6%.